Hello, everyone, and welcome to the Weekly Space Hangout for Wednesday, November 29th, 2017. I'm Fraser Kane, publisher of Universe Today. Universe Today? I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about problems with the WFIRST telescope. What a surprise. Mapping the 3D motions of extragalactic stars, flowing rivers of sands on Mars, and low power lights are killing our dark skies. Joining me this week, it's our regular crew. Let's start with, I think we got Morgan Renberg. Morgan.
Hey, Fraser, I don't want our dark skies to die.
Well, then go back to, we'll talk about it later. As well, we've got Paul M. Sutter.
Hey, dark skies are overrated because you can just go up into space.
Someone actually said that to me on Twitter today. Like, who cares about dark skies? Let's just build more space telescopes.
It's not expensive at all, as we're about to discuss.
It's the simple solution. And of course, last but not least, Kimberly Cartier.
Hey, Fraser. Hey, viewers. I love dark skies. They're the coolest. We should keep them.
Well, there you
That's
go.
my
A split panel today. It's going to be a lively discussion.
It really will. All right. So before we get on with the actual show part, we've got a giveaway to do. Ooh. And we've got 2 copies. Now, we did an interview with friend of the show, Dean Regas, who is the astronomer from the Cincinnati Planetarium. Mm-hmm. I believe that's close to you.
Down the road.
Paul.
Just down the road.
Yeah. So this is his book. We've got 2 of these to give away. You had your chance to send in your email. So now I'm going to pick 2 random numbers.
Oh. Drum roll.
Yeah. From 1 to, let's see, what's my number here? 1 to 53.
Those are pretty good odds.
I know.
Nice.
So the first winner is Richard Oken, or is it ZeroCon? So that's the first person.
Yay!
Yay! I'll put that in the chat. And then the second winner, there's one. And the second winner is Richard again. No. Anja Saxey. So I'll put that in the chat as well.
You got to fly to British Columbia to pick it up.
You too. We cannot pronounce any of your name, but you're still winners.
So, so congratulations. You were the people who sent in your names.
Anya. It's Anya Saxey.
Anya Saxey. Sorry, Anya. Yeah. Those are the people who sent in their emails for our 100 things to see in the night sky. And you're both going to have a copy. I'm not sure how this is going to work out. Nancy Graziano's got this all figured out. So I've done my part. Right, Nancy? Right? Let's move on with the news.
We'll assume Nancy said yes.
Yeah, well, she's not actually here in the room talking to me. We have to wait for her to
Nancy's got this.
Put chats in the chat places, and we'll go from there. All right, let's get on. That's the technical term. Chats in the chat places.
The chat places?
Yeah. All right. Okay, Morgan, I'm like a moth to the flame. Tell me about what's going wrong with WFIRST.
Well, first off, what is WFIRST? It's going to be the follow-up telescope to the James Webb. Now, you might say, well, we're still at least 2 years from launching James Webb. Why are we already thinking about WFIRST, which stands for the Wide Field Infrared Survey Telescope? But the answer is it takes a long time to build a space telescope. When they were putting James Webb together, they figured it would take a decade to design and build. It's now been more than 2 decades and still no James Webb. So we're thinking already about its successor, which will hopefully, fingers crossed, launch in the mid-2020s. And unlike James Webb, which was trying to be bigger and better in that sense than Hubble, WFIRST is trying to be better than Hubble in a different way. It's going to be the exact same size, about 2.4 meters across its mirror. but it's going to be able to see more than 100 times as much of the sky as Hubble can at one time.
It's like
And so
the
it's going to make
Large
these
Synoptic Survey Telescope of space telescopes, right? It's going to have this
Yeah, that's
massive
right.
field of
Very
view.
large survey telescope dedicated towards cosmology and exoplanet hunting with microlensing.
Yeah, gimme.
Yeah, it's going to look at a patch of the sky at any given time that's about half the size of the full moon. And so this is huge compared to the size of what Hubble looks at, which we often describe as something like the penny in Abraham Lincoln's eye if you're an American and you hold that penny up to the night sky. And it's a pretty simple design in the sense that it packs only two instruments. One is an infrared camera with a resolution of 288 megapixels. And the other is what's called a coronagraph, which is the thing you put in front of a star to block out its light so you can try to image other things like, say, exoplanets.
So we know how to do coronagraphs. We know how to do infrared telescopes. We know how to build and launch something the size of Hubble. So what's the issue here?
Wide field of view.
Oh, the issue is that it's already over budget, and they really haven't started doing anything.
Yet.
Yeah, so it's still very much in the conceptual stage, and it's been assigned a provisional budget by NASA of $3.6 billion. But already an independent review suggests that as sort of spec'd out, it would cost somewhere in the neighborhood of 3.8 to $4.3 billion to build. And before this show was started, we were sort of kicking around the original budget estimates for James Webb, which started somewhere in the neighborhood of $1 billion. And now we're all the way up to $8.8 billion. And so you can imagine if we're starting here with a budget of 3.6, who knows where that's going to lead.
25 billion.
Well,
And yeah, it's hard.
Yeah. One of the big problems here is mission creep. I don't know if any of you guys remember SNAP, the supernova acceleration probe. This is there was, as soon as dark energy was discovered in the late 90s, there were a bunch of missions proposed to go hunt for more supernova using space telescopes and really pin it down. None of those flew. They were all rejected. And some of them evolved into what would become WFIRST. They collected a bunch of proposals together, made it WFIRST, and then that was rejected until the National Reconnaissance Office donated to NASA these two giant telescopes.
Right. Yeah, we've got these. I love that story. That they were like, oh, we've got these Hubble class telescopes just kicking around. They're not good enough for what we need. So go ahead, NASA, have fun and play around with them.
Yeah, that's pretty awesome. And
Point
also
them at the sky instead
and
of
also
just
frightening.
Yeah, it's also terrifying. Yeah.
And so NASA kept one to test, and then the WFIRST mission was revitalized using this new telescope. And everyone's like, hey, it's going to be super cheap because we got a telescope for free. We just have to get into space and like put some cameras on it or whatever. And it originally was going to be dedicated to cosmology missions. Supernova are a little bit passé for cosmology now and studying dark energy. So it was going to use other techniques for studying the expansion of the universe, but it was going to be a dedicated cosmology mission.
Yeah, sorry, not sorry.
Yeah. But then they realized its capabilities, since it's already looking at lensing of gravitational lensing. There's a technique that you can use lensing to search for exoplanets, so it became also an exoplanet hunter.
Yay!
And then more stuff happened.
So Morgan, where do we stand now?
Yeah, so the science head of NASA, Dr. Thomas Zurbuchen, sent the design back basically to the engineers and said, make it cheaper. And one of the things that they're doing to address that is to take the coronagraph and designate it what's called a technology demonstration. And this basically reduces the requirements for designing it in the sense that it's no longer sort of necessary to work for the mission to be considered a success. And that reduces the amount of sort of budget it takes to make sure it's going to work. But a lot of observers of this have basically said that this is just a cowardly way of canceling the coronagraph entirely. Because when you designate something a technology demonstration, it basically becomes an expendable part of the mission. And if WFIRST ever has another budget overrun, I just want you to sort of wrap your minds around that possibility. If that happens, one of the first things that would happen is exactly what Paul was saying, is that we do what's called descoping it. And descoping it means sort of throwing things off. And the first things that you throw off when you do a descope are the things that are optional. And when you have two instruments on your mission, one of them is labeled optional and the other is not, it's pretty obvious that as long as there's at least one budget overrun in the 20-year development cycle of WFIRST, the coronagraph will go away and we'll be left with basically a giant wide field space camera that can do some of the cosmological studies that Paul was talking about, but would be more limited in what it could do to study exoplanets.
Right.
There's one extra political wrinkle here. Well, there's a few political wrinkles to this. One is one of the reasons why so many things were added on to WFIRST is that the Europeans are building and designing an almost identical mission called Euclid.
Yeah.
It's also going to be Planet Hunter. That's also going to be a cosmological survey. They vary slightly in the breadth and depth of their survey strategies, but they're basically the same instrument. You can get a lot of the science from one that you can from the other. And so I think there was a lot of incentive to add extra stuff, kind of differentiate WFIRST, because we could say, well, the Europeans are already paying for one. And they're further along in the process than NASA is, so why do we need a WFIRST?
So doesn't it kind of feel inevitable that they're going to join these missions together the way they did with Hubble? Like, Hubble is a collaboration between NASA and ESA. James Webb is built by NASA, but it's being launched by ESA on an Ariane rocket. They've done this many times before. Cassini's a collaboration.
Right.
There's been many of these collaborations. Doesn't it make sense to just collaborate on this one?
I think if the NRO had never donated those telescopes to NASA, then the American cosmological community would have gone all in on Euclid and focused efforts there and built a lot of collaborations and flown one satellite that we all share and we all work towards. But since, and this is just my own personal observations, ever since the NRO made that donation and NASA was able to fly their own cosmology mission, a lot of the transatlantic collaborations that would have naturally developed just haven't. So almost every European cosmologist and exoplanet hunter is all in as part of the Euclid working group. And every American cosmologist is at least somewhat affiliated with WFIRST in some fashion. And kind of unwinding those collaborations and shifting money around, it gets harder and harder as years go by.
But it feels to me like the way to approach it is like the way they did with, say, WMAP, and then moving to Planck, and previous to WMAP was the what was it? COBE, yeah, right. And so you got COBE, which was sort of rudimentary, and then you got WMAP, which is much better, and then you got Planck, which is even better than that. It's almost like you take turns. But then you've also got the situation where you've got, like, say, the Mercury Messenger, which is done, and now you got Bepi Colombo, which is coming from ESA, which is also going to Mercury. I don't know, it feels like there must be a much better way to do this. But
well, one of the other criticisms that this report leveled on the project was that some of the reason for the projected budget overruns was problems with management from NASA headquarters. And basically that there were too many cooks in the kitchen, and it was not clear sort of where the buck stopped with various elements of it, and that was leading to some of these diverging paths. And if you have issues there, that might make it more challenging to then try to go forth and merge that with another mission, because there's, as Paul said, so many competing interests going ahead. Yeah.
One of the huge blows here was Neil Gehrels, NASA astrophysicist that was the leader of the WFIRST mission. He unfortunately passed away last February, and that took a big blow. Not just to the collaboration, but the whole process, because he was the guy who was leading it internally at NASA and managing all the external university collaborations. And so it was very, very sad and very tragic. And the mission itself, the progress of the mission suffered because it lost its leader.
Do you think that we're seeing like the rise of a lot of these ground-based observatories that are going to fill in some of those gaps? There are infrared observatories, not in the same wavelengths, but and there are, like with the LSST, there are these amazing wide field surveys that are coming on. There are exoplanet hunting telescopes in development that will be able to detect Earth-sized worlds from the surface of our planet. So it feels like a lot of that. And you're not going to get a coronagraph. Oh, some of them will have coronagraphs. So I think you're getting this.
Some of them already do have coronagraphs.
Yeah. So you've got this sort of rise of this Earth-based technology. At the same time, these monster telescopes, the super telescopes, as we like to call them,
that are still cheaper than the space-based telescopes.
And you can go and tinker with them, and you can put on a new camera, and that there's a lot of really good reasons. But then they've got these spare monster telescopes that they've got to do something with.
And that's a big challenge. And there's a lot of analysis, a lot of discussion of, if you take something like WFIRST and project out what kind of constraints you can get on dark energy, like the dark energy equation of state, which is parameterized using the letter W, hence WFIRST. You can do some reasonable projections, some reasonable assumptions, and say, okay, this is how much I'm going to learn about dark energy for the amount of money I'm going to spend on WFIRST. Well, if I can get 95% of that knowledge for half the cost using ground-based telescopes, maybe we should just invest more heavily in ground-based telescopes.
Yeah. All right, Morgan, I'm putting you in charge. Make the call.
I'm on it.
No. Right now. We need you to decide what to do. If you're in charge of NASA, make the call.
Well, if you can make 95% of the science for half the budget, then you should do that. That's an open and shut
I don't think that's one of the options.
What if you could have a really cool new space telescope?
Yeah.
Well, we can spend that money on a cooler, newer space telescope.
Yeah.
That will take 25 years.
So does NASA take that beautiful, National Reconnaissance Office telescope, put it in a museum somewhere, and
it belongs in a museum?
Make it look like Hubble. Because we're not going to put Hubble in the museum.
Oh,
Take
yeah.
that one, dress it up like Hubble.
If it's going to cost $3.5 billion to take a gift and make something useful out of it, then are we really saving money?
Yeah.
Or could we, come up with a clean sheet design that, was more innovative than sort of a 1990s era telescope mirror and get something better for that same amount of money?
Or
I think
just
that's
put it on the ground
an open
somewhere.
question.
Yeah, but the answer to that, Morgan, is James Webb. That is like a more advanced version, right? With all the hexagonal folding mirrors to pack it into the fairing. And that's not turning out so well.
And then move on to LUVOIR, right? Go for the full 18
for those of you keeping score at home, that's the space telescope after the space telescope. That's the space telescope after Hubble.
Yeah.
So we're like 3 or 4 generations down the line, and the drawing board
But we might as well get started now because we know it's going to take a lot longer.
Because in 5 years when it actually, comes up, it's already going to be over budget.
Yeah.
When is LISA going to go up?
In the late 2020s, 2030.
Okay, so never.
Yeah. All right, let's move on to another story. Man, we could just obsess about that all day, I think.
Yeah. It's too depressing.
Kimberly, tell us about mapping the 3D motion of extragalactic stars.
Yeah, so sort of going from dark energy to dark matter instead. Astronomers using a survey from Hubble from about 2002 and recent data from the Gaia mission were able to put together a map of the motions of stars in a galaxy not so far away, but outside the Milky Way in any case. The galaxy is called the Sculptor Dwarf Galaxy. It's a satellite galaxy of the Milky Way. It's about 300,000 light years away. And this was the most precise measurement of stellar motions we've ever had for stars outside the Milky Way. And so what they did over the course of about a 12-year baseline is they were able to map how about 100 or so stars in this very tiny, very dim galaxy changed over 12 years. And on top of that, they were also able to get some radial velocity measurements of some of these to get the forward and backward motions, to get 3D motions. And what this does is it helps us map the distribution of dark matter in this very tiny galaxy and start to verify our theories of how dark matter should actually work.
I think Gaia is my favorite space telescope.
The fact that it's going to map 1%, what is it, a billion stars?
It's a billion stars
in the Milky Way is just mind-bending.
Yeah. For those of you who aren't familiar with Gaia, the idea is that it's measuring how the stars move sort of left and right and up and down on the plane of the sky, so that we can see, sort of how their motion in the galaxy is projected against what we can see. And it's sort of like the Kepler of this field called astrometry, in that it's making incredibly, impossibly precise measurements that tell us a whole bunch about the way in which the local galaxy behaves.
And that's ESA's specialty. They have done, previously they did the Hipparcos satellite, which did the best sort of version of that survey in the past, and Gaia is the super duper version of Hipparcos to produce the billion star catalog, which is just, again,
it's
absolutely mind-blowing.
It's pretty crazy. And like Morgan said, this telescope does incredibly precise measurements of the left and right and up and down motion, called proper motion, across the plane of the sky. And that's exactly what it did for this galaxy. But one of the cool things is that it was able to do it for a dwarf spheroidal galaxy, because I can speak tonight, of course. And these tiny galaxies are thought to be almost entirely dominated by dark matter. They're very dim. Though they are quite a bit larger than globular clusters, they look just sort of like a giant star cluster, because they're so faint. They don't have a lot of dust. They don't have a lot of star formation at all. They're pretty much mostly dark matter. And so by tracing how these stars are moving within the galaxy, you get a map for the distribution of all this unseen mass that globular clusters can't give you.
And that's a very important problem, because we don't understand very well the finer details of the structure of dark matter. We know how it operates on galaxy scales and bigger, but we don't know if it's smooth peanut butter or chunky peanut butter at smaller scales.
What's the method to actually, if you know that this galaxy these smaller dwarf galaxies are mostly dark matter, what is the method that you go about to actually figure that out?
Well, you have to look at how fast these stars are moving and how the stars are moving, and compare that to how they should be moving if the mass was only coming from the stuff that you can see. So, for example, in globular clusters, we're seeing all of the starlight, and from that, we can get an estimate of how much mass all of the luminous stuff actually has. And based on that, we can project how the stars should move based on that distribution of gravity. And in globular clusters, we found that the stars can account for all of the gravity that's causing the stellar motion. But in these dwarf spheroidal galaxies and other very low surface brightness galaxies, the stars are moving in such a way that they have to be reacting to gravity that is not also luminous. And that's how we figure that out.
Arjun is asking in the chat, does dark matter surround a galaxy in an actual halo, or does it form larger web-like structures with a lot of galaxies in it? So if you could turn on all the dark matter, would you see these sort of balls of dark matter around the galaxy, or would you see these kind of tendrils and connective tissue between galaxies?
I'm going to bounce that to Paul.
That sounds like a Paul question.
That's a Paul question. Here we go. You would see both. So galaxies are surrounded by balls, which we call halos of dark matter. And also the galaxy clusters themselves are also surrounded by very, very large balls. But where you see the cosmic web with these long, thin streams, these tendrils, these walls, that is also tracing out the shape of dark matter itself on large scale. So there are streams of dark matter and walls of dark matter. We see this especially very well in simulation. So if you just type into a Google search, cosmic web, you'll see most likely an image from a simulation, and that is a simulation of the dark matter.
I'm going to do that right now.
He's doing it. I can hear it.
I'm going to put a picture up for the
Well, while
folks.
Fraser's doing that, I should also mention that for the measurements in the Sculptor Dwarf Galaxy, they actually were able to trace out what the distribution of dark matter should be. And it actually very well matches what our theoretical models say, in that the dark matter is denser in the center of the galaxy and tapers off towards the edge instead of being a nice, smooth, flat distribution of the same density all around. So the stars match the theory, which is really awesome.
So was
That we don't
Hubble's
know what
contribution to this measuring redshifts to get the forward-backwards motion of the stars? What we've talked a lot about Gaia. What did
Hubble's contribution here was to actually provide the baseline of where the stars were about 15 years ago.
You guys don't mean Edwin Hubble. It took me a while.
No, Hubble Space Telescope.
So there was this guy, Edwin Hubble, and then a few decades later, we named a telescope after him, and the telescope.
Got it. I thought it was the other way around.
It came late and it ran over budget.
Yeah. Hubble measured where the stars were about 15 years ago as a baseline, and then Gaia came along and said, this is where the stars are in 2014 and 2015. Here's how they've moved over the course of 12 years. And then there was also additional follow-up that got the radial velocity measurements.
That is awesome. I totally agree with Morgan on this one. Gaia has got to be one of my favorites.
So cool.
You can find exoplanets with it too.
Yeah, well,
that's
everything. The other thing. And so they're mapping out dark matter. They're finding exoplanets, and they are producing this incredible map of the stars, which we'll then use in our video games.
Yeah, and doesn't get a lot of good PR, so I like talking about Gaia.
Gaia is the best.
Lar Beckful says that it looks
sorry, Kepler.
A neural network, the cosmic web.
It does.
It does.
So much looks like a brain.
Purely, and that's the point. And this is where I'm about to again release the Kraken, which is, there is no connection whatsoever. They just look similar.
Totally different physics, totally different scales. The physics behind the cosmic web is super cool and very interesting, and I don't want to take up the rest of the time explaining it, except it's very, very different than how neural networks form.
But it's like we keep finding the golden ratio everywhere and fractals everywhere, but it doesn't mean they're at all related to each other.
All right. Wow, everything's all like switched up. It's Wacky Wednesday. Paul, you're talking about planetary astronomy.
Yeah, why not? Well, I wanted to intro the topic so that the experts could educate me. So by a vote, is there liquid water on Mars or not? Like, what's going on?
Well, why don't you give people the intro here, and then we can figure it out.
Okay. So there's this recurring slope Linnae? How do I say the last?
I always say Linnae, but that's probably
I say Linnae as well.
Oh, Linnae sounds way better than what I've been trying to do. These recurring slope Linnae. Thank you. These dark streaks that appear in the summer on crater walls and then disappear in the winter. We've been observing them for quite a few years. And then 2 years ago, we did some more analysis and figured out that there's a lot of salts in there. So it might be caused by hydrated salts, like subsurface water seeping out like a wet sponge and then slowly oozing down the hill and doing its thing. But then there's some more recent analysis that looked at the angle when these slopes stop, and it's more consistent with just sand stopping rather than liquid water stopping. And so they're arguing that water, even if it's present, doesn't play a very strong role in creating these recurring slope lineae. That sounds like Linnae. I was going to say that sounded way too Hawaiian.
Yeah, it sounds like a Hawaiian island.
Latin 101.
Or
Linnae. So what's going on?
So here's the kicker. One of these is within spitting distance of Curiosity. Like literally, they could drive there in like a couple months.
That would require
right there.
Water for distance.
And we can't go there because maybe it is water, and therefore we wouldn't want Curiosity to accidentally contaminate it and spread Earth life.
So it's in one of the anti-contamination zones.
Yeah, well, it's Well, Curiosity was never supposed to go places where there was water, so it was never sterilized expecting there to be water. And so we could answer this question by driving over there and checking it out, uh, but
Yeah.
we can't.
It's pretty funny though that you can't tell the difference from water streaks, discolored sand streaks, and some other substance that's maybe being ejected out of the side of the crater. And when I mean, I've been reporting on this for years now, and and the analysis all really sounds very reasonable. That as the temperatures warm up, you get perhaps these outpouring of material from some kind of layer that gets you cold during the wintertime and comes out in the lower pressure and flows down the side of this crater. This is
Honestly,
what we've all been saying for the
I
last couple of
I have to
years.
say that I've always been a little bit skeptical of these lineae as they were, melting and disappearing and coming back again. I've always been a little bit skeptical. It always sounded like we've been trying to make up some excuse for there to be flowing water on Mars, and this is the closest thing that sounded like it could be true. And then we made up this convoluted story of how it must happen. But there's, aside from the fact that we see these streaks that come and go, there was really no evidence that it was water that was doing it. For me, when I heard, oh, it's, flowing sand instead, I'm like, oh, that makes a lot more sense because it totally works with what we already know about Mars and what we've measured about Mars.
So how does the flowing sand change seasonally like that?
I don't know. Well, that I don't know.
So their explanation was that it still had to do with water.
Yeah.
And that as seasons changed, the moisture level in the top layer of the sand changes enough. And just like ice expands and contracts here on Earth, and that can break free debris, changing moisture levels in the sand could trigger these sort of mini landslides that appear as if they were water streaks.
So you've got a I guess hydrated water, rich layer in that wall of the crater. The seasonal changes are changing its structure, and it's causing this little landslide that's happening over.
But they're not wet, right? I mean, how
But
moist
the sand isn't
does something
wet.
have to be
It
to
doesn't
be
have
called
to be
wet?
liquid. It could just be slight changes in the density of the ice or in the placement of the ice that's shifting some of the sediment around, and it causes little avalanches. The thing that convinced me, I think, was the analysis having to do with the angles of the craters, where they only saw it in certain craters that had angles that supported sediment release, but the shallower ones where water should have been flowing, there wasn't. That one was sort of like, oh, that does that.
Yeah.
Does make
This
sense.
is good work. It's really good work. I'm not sure I'm quite as convinced as Kimberly is, because there are a lot of unanswered questions that the team sort of takes passes at offering answers to, but doesn't really fit within their fundamental picture. And the seasonality is one of those things. But the fact that you do see them only on slopes of at least 27 degrees, and that aligns really well with what we know about how landslides work, is compelling evidence. And it suggests that we shouldn't just assume, out of hand that this is water, when the situation clearly is more complicated than that.
Something like when you hear hoofbeats, don't assume zebras. When you see streaks, don't assume liquid water on Mars.
Wise words.
Wise words.
Yeah.
All right, so here's what I've got, and I'll go very quickly because we don't have a lot of time left. But essentially, a new survey says that the amount of light pollution, big surprise, is going up. And one of the problems of this is that we have been switching to these lower power LED lights. And these lower power LED lights, because they are lower power, people are actually installing more of them, and they're not actually getting the kinds of energy savings that they were expecting. And the other part is that essentially the skies have gotten 2%, the extent of radiance that's going up into the night sky has been increasing at 2% per year over the last 4 years, which is kind of a terrifying amount of light pollution that's going up. And the other, and so it goes kind of in lockstep with the gross domestic product of the countries. As they get richer, they are investing more and they're building more of these lights. They're putting them outside. They're brightening everything because the power is relatively cheaper.
So the
Killing
problem
the night
is
sky,
LEDs
and they're not
themselves,
saving the energy.
right? It's poor municipal management.
Well, I read it as sort of like everything else in the world today. As some people are trying to do something good, install low power lights, and then a lot of people around them counter that by doing something really stupid, installing even brighter lights to make up for it.
Yeah.
And the stupid people are winning out over the people who don't like light pollution, and thus we are here.
Sure.
And part of the problem as well is that the actual
light pollution conscious.
The wavelength of the light is a problem as well. So they're sort of the sort of traditional halogen lights they used had a sort of more of an orange tint to it, and now they're switching out to these more bright white lights.
God, those headlights are so obnoxious.
Yeah, well, I mean, the street lights. I mean, not just the car headlights. But I know what you mean about the car headlights. I'm getting.
Well, blue light or LEDs have a lot of blue light in them, and blue light is really bad for your body at night. So we're putting in more energy efficient, maybe more light conscious fixtures, but the health concerns of light at night might actually be getting amplified by the switch to LED, and that's sort of an unanticipated side effect.
Yeah.
Yeah. Plus, blue light destroys your night vision so much quicker, and it lasts for so much longer. So yeah, the areas that are lit brightly and you can see, but the areas that aren't lit are now seem so much darker because your night vision's gone away.
And this is a problem with
so add more lights
with our phones, right? Our phones have an LED screen. They put out a lot of blue light, and there are problems with that as well. So we're sort of entering this era where we've gone all in on LEDs, which, I mean, I've replaced every light in my house with LEDs. I love them. They're low power.
You can't really find the other light bulbs too much anymore.
Yeah, they're now they've gotten cheap, right? I'm lit right now with LEDs. Although I do find after I do a show and I've got the two lights staring in my eyes, I'm blinded for
like little spots.
I find the same thing.
Hours.
But the thing is, they also analyzed lights around Tucson, where they actually had more efficient light fixtures and more efficient lamps that directed the light where it should go, and the light pollution was low, which is good because it's near two really big observatories, and it was perfectly fine. We can do LEDs, we can do the power efficiency as long as we do it smartly.
But I mean, I don't think this is going to be a thing that we can stop, unfortunately, is that people want their cities to feel safer, and because the power is they're not as energy intensive, and they're on this decreasing Moore's law exponential curve that's going to bring the cost down. They're just going to put more and more lights outside, and they're just going to brighten it more and more.
I think I'm a little bit more optimistic than you, Fraser, because I think it's an opportunity here. Actually, it's one of the few things where we could raise awareness about this and initiate these conversations where we can recognize a balance between industrial needs, safety needs, and preservation of the night sky. And most people just aren't even aware, because most people haven't even grew up under a dark sky, so they don't even know what they're missing. And there are opportunities there to share with people the value and power of the night sky and the beauty there and the intrinsic value of astronomy to humanity and blah, blah, blah. And at least get that dialogue started, so at least there's some basic level of awareness so that we can make more informed decisions as communities.
Well, and there's one really big difference between light pollution and something like, say, climate change. And that's if tomorrow we woke up and all decided we were going to fix light pollution, we could do it and it would be fixed. There's no sort of long running. Once the lights get turned off, they're off.
Yeah.
And so there's hope at any point in the future that we'll come to our senses and do something about it, and it'll be fixed. And that's not true about, basically every other kind of pollution.
I now want to run an ad campaign on TV being like, this is your night sky. Yeah. This is your night sky on LEDs. The brain on drugs, but with LEDs.
I got it. I figured it out right away, actually.
The fact that people haven't had a chance to see the night sky properly is really sad, and that is something that it's almost like until they have some connection to being able to see the night sky and see the stars and the Milky Way and things like that, they're not going to take it seriously, and they're not going to consider it to be one of those things that they don't want to lose.
Fraser, do you know of any opportunities coming up where people can get a nice view of the night sky?
There's a place in, you mean the place in the Caribbean?
Yeah, I don't know. I just wonder if you knew of anything.
Oh, maybe.
Yeah, well, it's just another opportunity for us to mention that we're going to be in the Caribbean in September of 2018, and you can join us. Just go to astrotouring.com and register. And we're like 60% full. Like we're
60% capacity.
Are they going to turn all the cruise lights off for you?
No, no, they're not going to do
ship?
that. But we are talking to the cruise operators to try to get like a little exclusive dark spot for our group. We're working on that.
Yeah.
Very cool.
Yeah, it is tough because on the one hand you are far away from all the city lights, and you do see the stars and you do see the Milky Way as long as you stand in the shadow of the lights.
Mm-hmm.
In my experience, so it does
put you in a lifeboat and trail you behind.
Yeah, exactly.
Ship.
Yeah.
Yeah, that's what we're going to do.
All right. Well, now it's time for our interview. And our interview is over. All right, let's wrap things up. Once again, we don't have any kind of clever way to wrap up this week's episode.
Viewers, you're letting us down.
Yeah. It's you take all the responsibility for us not having some kind of clever thing that we need to finish with. So
Maybe we've been doing such a great job with our closing so far that they don't feel the need to.
Yeah, they're blown away every single week with us awkwardly saying goodbye.
Well, you know what? We don't have a lot of time, so I think we will just have to say goodbye. But I think you should just take a moment to shamelessly self-promote something that you worked on in the recent time. Paul, what have you got going on apart from a cruise?
Apart from a cruise, well, there is my radio show, spaceradioshow.com, where every week I take listener questions and talk about the news. And it's lots of fun and very spontaneous because I have no idea what I'm going to talk about. We record every Thursday at 4 p.m. Eastern. You can go to spaceradioshow.com.
You just did a super fun collaboration.
I just did a super fun collaboration on my YouTube channel with John Michael Gauthier on peculiar stars, past and future in the universe. It's a two-parter, part one on his channel, part two on my channel. So you can go to youtube.com/Paul M. Sutter to check that out.
Perfect. Morgan, what's something you just did?
Yeah, if you want to learn something cool about your world, check out my website, chartyourworld.org. Find something that interests you and share it with the people that you know.
Kimberly?
Well, so I've actually been taking a small break from publishing because everyone at AGU, American Geophysical Union, is all gearing up for our big fall meeting.
Woo!
25,000 geophysicists are all going to gather and talk about science.
How many geophysicists does the world need?
A lot.
25,000.
Where's it happening?
It's happening in a week and a half in New Orleans, Louisiana, right next to the French Quarter. So I'm super excited about that. I've never been to Louisiana before. Never been to New Orleans
super
before.
fun. Make sure you get some beignets.
So excited, and I'm going to learn all about geoscience. And so I've just been reading all of the science. And so right after that, you can look for a bunch of stories from me.
Have you ever attended a conference as a journalist?
I have never attended a conference as a journalist before, so I get to be in the press room with my press badge, which just came in the mail, and I get to ask all the impertinent questions about people's science and pretend like I don't have a tape recorder with me.
Yep.
And
it will destroy you.
Yeah.
Wow.
Encouraging.
That's all I have to say about that. Like
and
pace yourself. Stay hydrated.
And then a week after that, there's the astronomy conference here in DC.
Yeah, well, that's when you will have learned all your terrible lessons from the AGU meeting, and then you will be,
It'll seem like a walk in the park.
Yeah, exactly.
I've been to the astronomy meetings before, but the geoscience meeting is like literally 10 times bigger. And I say literally.
All of the actual conferences that I go to try and cover on location, I just get worn out and destroyed. So it's
So we'll see
it's
how
a
that
lot of work.
goes.
Yeah, no, have fun.
We'll see if I, tune in that Wednesday night to do a podcast, or if I'm just going to be completely mentally destroyed.
Yeah, that sounds great.
Great.
So, and for me, we just posted a new episode we did about creating artificial magnetospheres, which was a lot of fun. Short answer, no, can't be done. It's not worth doing.
I could have told you that.
Yeah, I know. I wish I just asked you in advance.
No.
But I talked to the director of the Italian Space Agency, which was a lot of fun.
Very cool.
So, yeah.
Shame about the magnetospheres, though. I know some exoplanets who could use one.
It's not that it's not possible. It's just that it makes more sense to build a fort of your supplies around you to protect you in your spaceship than to try and create some kind of artificial magnetosphere.
Can it be a pillow fort?
Yeah. Well, there's
As long as your pillows are made of water.
video of the
Bouncy
astronauts
castle.
building a pillow fort around themselves to protect themselves, and then they have to stay in it for a couple of days sometimes if it's a bad solar storm. But yeah.
Fun.
All right. Well, hey, let's wrap this up. I'm gonna put you all in the view. There we go. Thanks everyone for joining us. Thanks as always to the Weekly Space Hangout crew for organizing and being part of the live chat that's down there. Go to wshcrew.space, and thanks to Nancy for organizing the guest and the giveaway that we did this week. That was a lot of fun, and I hope we can do many, many more of them. All right.
Thanks, Nancy.
We'll talk to you all next week. Okay. All right, joining us this week is Dean Regas, author of 100 Things to See in the Night Sky, which I'm holding up. It's nice when the book publisher gets me the book so that I can actually hold it up. You see that, all other book publishers? Get me the book. It's worth it. Dean, welcome to the Weekly Space Hangout.
Hey, good to be back with you. Thanks for having me.
Man, so you wrote a book?
I did. Oh, look, I have a copy too.
You have a copy too. Look at this. Boom.
Everybody
Look
should
at
have a
that.
copy
Everybody
of
can
this.
see it now.
Yeah, 100 Things to See in the Night Sky. This was an idea that I had to try to get pretty much everything that you could see with the naked eye, the highlights, the top 100 things. And so this starts off the sun, planets, but then it's my favorite stars and constellations. And most of these things can be seen in urban locations, naked eye stuff, but then you could jazz it up and use telescopes and binoculars to see a few things a little better.
Right, and I'm definitely not the greatest observer, but I know my way around the night sky. I can get a bunch of my constellations and find various star clusters and things like that. So what sort of level are you aiming at when you put this list together?
Yeah, it's mostly for the beginner. This is kind of the starter. The way I tell it is this is kind of the blueprint that I followed when I changed from a normal person to an astronomer. When I made my conversion to the stars, and because when I started, I didn't know anything. I didn't even know where the North Star was, and I was thrown into working at a planetarium. My boss, you got 5 days. Your first show's in 5 days, and I knew nothing. And so I needed to start from total scratch. And it was this kind of information that got me going, because I just really want you to get a foothold to the sky, because it can be kind of intimidating. But if you can pick up, 5 to 10 stars, 5 to 10 constellations, and then start from there, it really snowballs after that.
Yeah, I think you're right. The funny thing is, I did all of my amateur astronomy back when I was a teenager. I bought my own telescope at age 14 and was out, and I spent a couple of summers pretty obsessive about it, a few winters, although, we get a lot of clouds here, but I did sort of learn. And it really is this pattern matching where you find one thing and then that teaches you how to find the next thing. And then you start to have this structure in the sky, and it's funny even now, when I look at people's pictures of the Milky Way, I'm like, oh, there's Sagittarius, there's Scorpius. You can see the constellations and they stick with you forever. So where do you typically recommend that people get started, and what's sort of the process? Should they get their telescope? Should they get binoculars? Or naked eye? Where should they start?
I know that's a big common question. I want to get a telescope. Where do I start? And so my first answer is don't buy a telescope.
That's
Please
mine
don't
too.
buy a telescope. Start with learning the night sky. So with the book, the main constellations we focus on are main star patterns. First, find the Big Dipper, of course. That's a big landmark for the Northern Hemisphere. And then Orion is the other big landmark in the sky. And I know people get frustrated when they're thinking, okay, all right, these stars don't look like a queen. This doesn't look like Medusa. And we try to get past that and say, look for shapes in the sky. We want to look for stars that make a big square. And
Yeah, look for the backwards question mark.
The backwards question mark for Leo the Lion.
Right.
Exactly. And I also try to look at it to how people in the United States learn their states. That we can identify our states by shape. And so we have this mental map in our head of, okay, so if here's Ohio, we know what all the states are in Ohio. And we just say, make Orion your Ohio. If Orion is in the sky, then you can figure out where everything is in relation to it.
Yeah. I mean, I think, with many of these hobbies, as you start to learn the details and the technical parts of it and you become more and more accustomed to it, then it brings a much richer meaning to it. Like when you go out and you see various kinds of birds, you're like, oh, it's a bird. But if you're a bird watcher and you know your birds, and you're like, oh, that's a male junco and there's a female and that's a towhee and so on. Those are the birds we have around here.
Oh yeah.
But it's the same thing with the night sky, which is that it's one thing just kind of go outside and go like, wow, look at all those stars, if you've got like dark skies. But it's another thing to know, oh, look, Orion is just coming up, or wow, I can really see, oh, it's the first time I've been able to see Pleiades and so on, right? They are these moments, and you can just walk outside and look outside and see the stars, and it kind of shows you where you are, and I think that's really great.
Most definitely. I mean, like you have different seasons that you can kind of associate with constellations. Like now that we're in the fall winter time, we got the Seven Sisters that are coming up, and Taurus will be coming up soon. And then Orion, you think of him for wintertime. And so, yeah, there's a couple ways that I like to try to describe just getting started in astronomy. And one is you're kind of hinting at it for me, is like, so you have enough knowledge to go outside and impress your friends, right? You could go outside and say, behold, that is Jupiter up there. And people they think it's cool, right?
Yeah.
If you could point out a planet, that's pretty awesome. And once you get started in it and you get, maybe it's on power on stuff, but once you start being able to identify some of these things, it really starts getting into you, and it's great to go out there and say, hey, look, there's Jupiter up in the sky, there's Orion, and they're right there for you, and it's really cool to share that with others.
Yeah, the one that I always think is so funny is every 18 months or so, people are like, what's that bright star in the sky? How come I never noticed it before?
I know.
A star. It's Venus, and it's reaching its greatest elongation, and you're finally noticing it. But
oh yeah. One of the October kind of star that really gets people is Capella. In early October and November, when it starts rising in the northeast, people say, "What is this twinkly star that's it's flickering red, white, and blue?" And it's this great star Capella. I call it the Twinkler, the notorious Twinkler, and you can check that out. Sirius will be the next one coming up in December and January, and then Venus will be coming back to the evening skies next year. And so we'll get all these calls at the Cincinnati Observatory saying, "What is that UFO in the sky? And how did I not see it before?" And it's there every year. It's like clockwork. We get these same calls.
Yeah, absolutely. I know the experience. I've gone and done whole videos just on them. So then let's talk about some of these sort of first projects that you do. You're talking about learning the night sky. So and the thing that I like about what you've done with this book is you're giving people one little unlockable achievement at a time, and that each one builds from the previous one, and relating to the time that you are. And so as you kind of move through, you're both going to identify the overall constellations, but also move into those. So what is the journey that you're sort of encouraging people to make?
Well, yeah, I think I think you got it just right. Is you want to build on the easy stuff first, and that's actually kind of one of the additional thing book is an object of the 100 things has a rating. It's either easy, moderate, or difficult. And so you can just start with all the easy ones and find them. They're like first magnitude stars, really bright things, really easy to identify. And if you get through all those, then you can move up to the moderate. And then if you really get serious and want the challenging ones, you get to the difficult ones, like the Andromeda galaxy that you can't necessarily see with the naked eye if you're in the city, or the Hercules cluster, which is, I snuck that in. That one is technically visible to the naked eye, but you got to be in like perfect conditions.
Yeah.
But then I break it down by season. So we give the highlights of the winter season, what to look for. And it starts with kind of an overview picture of all of the sky for the winter sky, and then how it changes to the next season will be spring. And then you just, each season has its own highlights.
Yeah, it's that's great. And so, like right now, what are some things that people should be going and looking for?
But yeah, we're almost into Ryan's season. If he rises up about 10 o'clock or maybe a little later right now, but we're starting to get into the winter sky will be coming along. But the Seven Sisters, they're also called the Pleiades, are great. They're in the eastern sky, about halfway up in the sky. They look like a little cloud at first, but then when you look a little closer or look a little with averted vision where you don't look directly at them, then you can pick out some individual stars in this cluster. And this first grader, when I showed it to him once out at the observatory, he's like, hey, let's call that the Dinky Dipper, because it looks just like this super small dipper. And of course, it takes like a first grader with unbelievable eyesight, not me with my 2,500 vision. But yeah, you can see these little stars, and then you can point binoculars at them, and they really come alive. We've got Taurus is also coming up just below the Seven Sisters. Looks like a little V shape that's that direction up in the sky, and that's really cool. And Cassiopeia way high up in the sky. And unfortunately, right now, we don't have the Big Dipper to see. It's kind of too low in the sky for us to see right now. But we've got Capella in the northeast and Vega in the northwest that are just these bright beacons, these really bright stars that you can find too.
Well, speak for yourself. I guess I'm a little more north than you, so we've got the Big Dipper all year round. It just sort of spins around and around and around the north, the Polaris. So
perfect. You can use that to find the North Star all year round.
Absolutely. Yep. Yeah. And that's how I learned to do it too. You look at the two stars at the end of the Dipper, and they follow this path up, and they show you exactly where Polaris is, and it's not the brightest star in the sky.
Oh, there you go. Exactly. And that's a real common misconception. People say, oh yeah, that's the brightest star in the sky is the North Star. Absolutely not. It's about the 47th brightest star in the sky. And, in fact, North Sky is bright stars. If you see the brightest star in the sky, it is west, south, or east. It is never north. So that's one thing to learn first. And you said it exactly right. Boy Scouts around the world know that. You find the Big Dipper, follow the two stars in the end of the spoon, and that points you up to the North Star. Nicest way to find it.
So let's talk a bit about some of the more transient things that happen in the sky. You've got constellations, you've got some of the brighter naked eye objects, but there's a sort of a whole section just on like satellites. And so what are some of the other kinds of things that people can get accustomed to finding?
Yeah, well, what I found in my teaching about the stars and constellations is we're outside under the stars, and people just notice satellites going overhead, and that has to be part of our arsenal of things you can look for in the nighttime sky. We've got the International Space Station, which is incredibly bright, almost as bright as Venus. It went over Cincinnati yesterday, bright. And then some other sites called iridium flares. These are old communication satellites. The sun hits the body of the spacecraft and beams down right to you, and are incredibly bright. They're almost like startling UFO sightings. Have you seen one of those?
I have seen one, but I get emails all the time from people, and they're like, I saw this thing. It was this really bright flash, and then it disappeared. And and then I say, like, oh, sounds like you saw an iridium. I don't know if you've heard, but they're shutting down the network, so we're gonna stop seeing iridium flares.
Oh no!
Yeah, in the next couple of years.
So man, because those things are so amazing. Because, and then when I'm out there with a group and I'm showing people the stars, I say, "Oh yeah, there's a satellite coming overhead." I called them up and I told them, "Come on, you can fly overhead for me, right?" And they're like, "Yeah." No, it just happens to be going overhead, and it's amazing to say, "Okay, you look right there," and 5 seconds, 5, 4, 3, 2, 1, and this bright thing, and just the people will go crazy, like, "Whoa!"
Yeah, your
And
ability
so,
to predict that
oh
exact
yeah, I
moment.
know. Again, astronomy going to my head here, but so yeah, the other one that I put in the book is the super secret spacecraft. That's called, has various names, X-37B and OTV-5. It's this unmanned orbiting craft that goes around the Earth from time to time, and we don't know very much about it. But we know it's there because amateur astronomers spotted it a few years ago, and they charted its path, and so they could predict when this super secret spacecraft goes up there. What it's doing, nobody knows, and
Yeah.
nobody asks. Well, actually, we ask.
We ask.
Nobody tells us.
Yeah, no one will tell me what it is, what it's
But
doing.
I always like that story because people say, well, couldn't the government hide alien crafts flying by? It's like, they can't even hide this craft, us. I mean, we're just amateur astronomers. We found it, so they're not hiding very well if they can keep the spacecraft from us. We could see it goes around the Earth every 90 minutes. We could see it every time.
Now, you mentioned that people shouldn't start with getting a telescope. They should go out, they should search the night sky, they should learn, they should follow your guide, learn with just their own eyeballs. I always recommend going to a pair of binoculars after that, but people are going to want to buy a telescope. So, so what right now are you liking in the telescope department?
Well, I'm a big fan of the reflectors and the ones on the Dobsonian mount. So I'm a big Dobsonian guy. I don't like all the computers. I don't like the go-to, it's all electronic. I like the things where you can just push the scope and aim it where you want. And
That's funny. I'm precisely the opposite, but maybe I've spent too much time. I've spent too much time pushing the scope, and sort of fine tuning. You're like a little down, a little side. Oh, and then it's moved out. Like, oh, come take a look at this. It's Saturn. And they look, and there's nothing in there, and you have to like go and especially with the Dobsonian because it's not on the it doesn't have an ecliptic mount, so you've got to kind of you've got to go step it to catch up with the object that you're seeing. No way. I love a computer to keep my telescope on target. I love a computer to.
That's cheating, Fraser.
It's
That's
totally
cheating.
Absolutely no. I freely admit that I am a lazy old man, and that what I want is I want my telescope to just find me this. I want to beep boop, but I mean, I guess that's what you get once you've gotten to a place where you do know your night sky and you do know your constellations. You can find this stuff by eye, and if I did need to sit in front of a Dobsonian, I could find you Orion's Nebula, but. Boy, it's sure nice to just kind of beep boop and make the telescope just go to its location.
See, if you're lazy, I'm cheap. That's what it is. It's because if you buy a scope that has electronics on it, doubles the price of the scope essentially. And so I have a good example, except now I can't pan over there. I'm at home and my telescope, my 12-inch push 2 is over here with its computerized mount and everything. I have not gotten it to work. And here I am. I mean, this is my job, and I can't get this computer thing to work. So, I basically have a Dobsonian, a gigantic Dobsonian 85-pound telescope sitting in my my house. But for beginners, I think getting bogged down with the computerized stuff is a little tough. And once you get to more advanced, then you can work on that. But I like to get the biggest mirror that you can get for the price. And so there's these ones you can get a 4.5-inch mirror scopes for about 200 or so, and then you get these 8-inch diameter scopes for about 400, and those are just awesome.
Yeah,
you can see a lot of stuff, that's for sure.
Definitely like planetary stuff, the moon. So you've got some solar filters. You can see some, you can see the sun, and you can see some of the brighter objects. I always feel bad though for people because we've seen so many pictures from the Hubble Space Telescope, and we've even seen some amazing pictures that come from amateur astronomers. And the pictures are amazing, but it is the camera that's really doing the heavy lifting, not necessarily the telescope itself, right? It's the fact that it's gathering photons for a long time, not how big the aperture of the telescope is. So.
I know those pictures are really get people spoiled, that's for sure, because they expect to see these beautiful color, elaborate, detailed pictures, and most of the faint stuff like nebulas and galaxies just look like little blurs. But for the moon, awesome. Planets, pretty awesome. There's a good number of star clusters that look great, a couple nebulas, and these are things that, so you have to kind of have your kind of your resources ready, but keep your expectations a little lower. The other thing that we recommend is to hook up with your local astronomy club or observatory or planetarium, because they often have lots of these telescopes and members that like to show them off. So if you go to an astronomy club, they like to kind of show off what the telescopes do. And so you could kind of get a preview of which ones you like better. Yeah. And I always like recommending that, because there's amateur astronomy clubs all around the world, and they love teaching at the same time.
Yeah, that is always my advice as well, which is like, just, you should be able to find a local amateur astronomical society in your neighborhood. Go find out when they're doing an open night. Go and just check out all the different telescopes and talk to the owners and see what they think, and they can tell you whether they like this scope, whether they like this mount, etc.
Exactly. It's kind of the brotherhood almost. This special society that people really get into this. And you go to any amateur club around the country, around the world, they're all very similar and very friendly and open to education. It's really great.
Perfect. All right, Dean, so where do people find out more about you and of course get the book that we're both
Sure, I'll hold it up here too. Yeah, 100 Things to See in the Night Sky. So you can get that on Amazon and pretty much all over the place. Just look for that. And I have a website at CincinnatiObservatory.org. You can check me out there. That's where I have a list of all the things going on, articles that I've written. I'm also the co-host of the TV show Stargazers. That's the show that's on PBS stations all around the country. Yeah. And they can watch some of the episodes there on the website. And this year I started a podcast called Looking Up. And so you can check that out as well.
Terrific.
But yeah, go to CincinnatiObservatory.org and you can see all the other stuff going on. I don't have my other book, but I have another book that came out last year called Facts from Space, and that's still available. And they even changed it, they adapted it into a calendar form. So it's a page-a-day calendar, a fact-a-day calendar. So check out Facts from Space, too.
Fantastic. All right, Dean, thanks again for joining us on the Weekly Space Hangout, and keep looking up.
My pleasure. Thanks for having there it is, backward.
you had it set for the Southern Hemisphere.
I know, that's right. Actually, that's next up. They've commissioned me to write a Southern Hemisphere version of this, so that'll be out next year.
Fantastic.
So we can talk to all of your big fans in Australia and South Africa and South America next.
That sounds great. All right. Take care.
Thank you.